Hello and welcome to a sneak preview of version 5 of SolidSteel Parametric for SolidWorks. This much I can reveal right at the beginning. There are new functions that make working with SolidSteel even faster and more comfortable. I will show the functions on a steel framework that will look like this in the end. Let's go! We start as always with a sketch from which we create and save in assembly. Of course, we need some profiles at the beginning. Since the dialog remembers the last used profiles, I don't need to select anything new here and can insert the columns directly. Okay. The first horizontal beam follows. It is initially inserted exactly centered on the system line, which is quickly corrected here in the menu under Parallel Offset by selecting Top. The other profiles are added quickly, since SolidSteel of course remembers the last input here as well. Looks good, we can confirm. Now only the two smaller stage beams are missing, which we insert as IPE 180 profiles. Again, flush with the top edge. Good, it already looks a bit like a steel frame. Now let's move on to the connections. We'll start here at this point with a double end plate. This is the profile we want to connect to this face. SolidSteel of course now suggests the end plate that we used last. I recently saved this end plate as a preset, and will now select it again for this demo like so. Now we can place it directly. There you can see the end plate including all bolting. Okay, so far everything was as usual. The first new function custom joints follows. For this, let's take a look at this corner. Here we want a frame corner, which we could of course construct manually. But instead, we will use the new function insert custom joint. We first select the end beam, and then the cross beam. As you can see, I have prepared something here in advance. The workflow of creating your own custom joints will be the topic of a separate video soon. After the selection, a very detailed preview of the frame corner appears immediately. In the options we select that the beam should be cut, and that we also want to insert the bolting. Now all we have to do is confirm, and the frame corner is placed within a few seconds, including all the fasteners, ribs, etc. I have also prepared a custom joint for the stage beams, so here too, we would like to connect this profile to this one. Select custom joint from the list. Activate the cut and bolt options. Preview fits, so we can confirm. Okay. Again, a few seconds later we see that the joint has been completely added, including notching, bolting, and the rib. I think you can already see that this new feature can save a lot of time, right? Feel free to show it by clicking the like button. I'll be happy about it. But now let's proceed, because I'm sure you've already asked yourself if the connections are parametric. The short answer is yes, they adapt to new positions, but not to changes in the geometry, as known from the standard connections. For example, if we now edit the sketch and say the width should only be 3,200 mm, and we also change the height to 2,800 mm. Alright. As we can see, nothing happened for the moment. This is logical in the way SolidSteel works. With a simple click on Update, SolidSteel takes a look at all the parts within the assembly, repositions them if necessary, and also moves our connections to the correct position. As we can see, all connections have now been correctly adjusted here as well. I'd say we'll just go ahead and finish building our complete framework now. I will fast forward a bit, so the video doesn't get too long. Let's start with the end plates and add them in places where there aren't any so far. We'll continue with the frame corners as custom joints. I'll also set the pin in the dialog so that the menu remains open. Okay then, let's take a look at the center and add the missing joints here as well. This is really fun because the new feature is a time-saving machine. It doesn't do anything that we couldn't do manually, but if you take a look at the video where the custom joints are defined, you can see how many steps would be necessary to get the connection done in full detail. The time you can save in your daily work is enormous. Speaking of time, real time up to here was 7 minutes 45 seconds by the way. Okay, now our framework is almost complete. What we're doing next is new in SolidSteel version 5 as well. We can now insert bracings fully automatically. Previously this was only possible via the assembly manager with multiple steps. I have already selected one from the database, and the bracing dialog shows me in the image in which order I have to select the points I want to place the bracing on. I activate the pin and confirm. This takes a short moment. The bracing is inserted as an independent copy and then placed accordingly in the assembly. Here, on the opposite side, I also insert a bracing. The dialog is still open thanks to the pin. I select the template, click the points in the correct order, and confirm again. Okay. Both bracings are in place but not completely finished yet. We still want to connect the bracings with gussets. We could have added these gussets to the bracing template, but I didn't do that because I would like to show the gusset function here as well. As always, we select the plate to be connected and the target surface. The last gusset plate I used is now suggested, but I'll just select the same presets again. I confirm the dialog with the pin activated, because we want it to stay open to set 7 more gussets. Continuing down here, we'll just select and confirm. While the other connections are being added, I would like to point out another new feature. The gusset plate tool can now also adopt boreholes. Up to now, the gusset plates have specified the hole pattern. Now it also works the other way around. For example, if the connection plate of the bracing is a standard part, then the gusset plate takes over the existing holes and only the screws must be placed in the matching holes. Well, a few more connections over here. This is of course now kind of a batch process, but since the PMPs remember the inputs, I can just work through it once the parameters are set. That wasn't the case in the earlier versions, and that also saves a lot of time. Okay, with this we are almost done with our framework. Real time up to here was 11.5 minutes by the way. Let's continue with the connection between these two beams. This could be done with a splice plate for example, but I'll choose the miter plate. So I just select both profiles, choose a standard which is in this case simply in European standard plate, and confirm. With the miter plate, both profiles are now shortened and the joint remains exactly in the middle. If I had used the double end plate here instead, only one profile would have been cut. Again, SolidSteel remembers the input, so for the second side I only have to select both profiles and can confirm immediately. And we are done with this step. The last thing that is missing are the base plates. Here too, SolidSteel offers the appropriate tool with the same name. We only select the profile and immediately get the preview with the last configuration used, here in my case was shear stud. I leave it like this, but of course other variants can be selected here as well. Now let's quickly add the 3 missing ones. For the base plates, there is also the option to add the plate below the profile or to shorten the profile by the thickness of the plate. Here in the example, the foot plate is now simply added at the bottom of the column. In practice, it is usually the case that the sketch corresponds to the final dimensions, so it is very convenient that the columns are then automatically shortened. Alright, we have now completely designed and detailed our framework. Real time 14 minutes. If you talk less than I did while working, I'm sure it would go a bit faster, but even like this it was a pretty good time. Sure, a certain amount of preparation is needed for the new tools, but since we often have to deal with recurring connections in steel design, the one-time preparation pays off. Now, as we all know, after the design is before the production, and a very important aspect in this context is the identification of identical parts. We start the identification here on the right in the task pane and select the tab position numbers. A click on Update starts the assignment of the position numbers, which takes a short moment. Here in the list we see that identical welded assemblies as well as identical parts have been assigned the same position numbers. With these position numbers, the base for the creation of parts lists is set. As a first variant, we will now create a SolidWorks parts list. Here in the menu, we first update the metadata. This update takes a moment, because there is a lot happening in the background, since all the available information that exists about every single part is directly written into it. Let's take a look at the results. As an example, I'm opening this profile now. By the way, this is a good chance to show that all the edits have been made here on part level. But back to the actual topic. We can now see here in the custom properties everything that is relevant for this profile. Material has been assigned, length has been defined, weight has been written in it, and of course the item number including a hierarchical number have been set. This means that we can also group identical parts together accordingly on the SolidWorks parts list. In other words, we have extended SolidWorks with a geometric identical parts recognition function. Okay, now let's write a bill of materials as it is common in SolidSteel. To do this, we simply click on Export BOM in the Bill of Materials menu. Select the BOM list in the menu and also the English header. The assembly is already correctly selected and we select the location where the file is to be saved. This takes just a couple of seconds, while the bill of materials is exported in Excel format. The Excel format has the advantage that it is easily readable by both humans and machines. Let's take a look. We see the bolt list, the saw list, where no angles are entered here because all cuts are right-angled, structure list, the beam list, the sheet list, the quantity list. It's a very well-structured list of all the parts that are included in our design, or in other words, all the information that is needed to manufacture them. Okay, I'll end the video here. I think there was a lot to be seen. The further process chain in steel design is of course also considered by, for example, automatic generation of shop drawings or export of DXF, SDNF, and DSDVNC data. But that has already been shown several times in other videos. If you have any further questions, feel free to contact us via our website or social media channels. If you like this video, be sure to leave a like and subscribe to our channel. Thanks for watching. Until next time and bye.